All right, so we're going to finish up the t-test that we were working on. So we'd already done the hypotheses. We calculated a test statistic for the t of negative 2.83. If we're using the calculator, step 3, where we go ahead and find our p-value, is very easy because all we're doing is pulling the p-value off the calculator, and that's 0.0045. If we have to use the table, life is a little more difficult for us. So we know if we're going to use the t-table, there's a couple of things we need first. We need our degree of freedom, which is n minus 1. In this case, our n was 26 minus 1, so we're looking at a df of 25. And we're going to be looking at our t-table for this negative 2.83. Now remember, our t-table only does right side probabilities, so we're just going to look up positive 2.83. So let's go ahead and go to that t-table. So we said that the df was 25, and we're looking for positive 2.8. So we're going to go down this row until we find something close to that. Okay, 2.8 would be somewhere in between these two values, right? Between 2.7 and 3.0. It's a little bit closer to this side, but that doesn't matter. It's not there, which means our corresponding p-value, or our corresponding tail probability, is somewhere between these two values. So 0.0025 to 0.005. So table, folks, now we have 0.0025 to 0.005. That's our possible range of p-values here. We know our p-value. We don't know exactly what it is, but it's somewhere between those numbers. And we can even see here from the calculator people, sure enough, 0.0045 is in between those two. And it's a lot closer to the 0.005, which was the one for 2.7. No need to multiply this range by 2 because we're doing a one-tailed test, right? We're just looking for that one-tail probability. Now we're back together again. All we're going to do is make and justify our decision just like we did in the last question. So first thing I'm going to do is start with the justification. How does our p-value, whichever one we use, how does that compare to our alpha level here of 5%? Both of these p-values, right, this range and this exact number, are way smaller than 5%. They're both less than 0.5%. So we got a small p-value, which means we're going to reject the null, reject that hoe. And so when we interpret our interval, we get to say there is enough evidence, or there is sufficient evidence to conclude, to suggest. And in this case, again, look at that last sentence, sufficient evidence to show the mean travel distance between oil changes has decreased. Perfect wording. We can just go ahead and steal that. The mean travel distance to show or conclude, whichever you want, the mean travel distance between oil changes has decreased. And again, you could also use the wording or say is less than 3,500 miles. Either way works. If you do use the actual number that's here, make sure you include the units of it. Don't just say is less than 3,500. All right, so then we get to see some of the other questions that come along with hypothesis testing. I can obviously change any of these steps into multiple choice. That's one option. That's what number 2 was. So number 2 says, okay, look, I have done step 1 for you. I made up some hypotheses. I also did step 2 for you. I found the test statistic. We know if we're talking about hypotheses with a p, this particular test statistic is a z, right? And then it says, which of the following is the correct p-value? They're asking us to come in and do step 3, right? They did this for us, they did this for us, and they're saying, find a p-value. Since we're doing a z type of test, right? Since it's for proportions and that involves a z, we just need to look this up on the z table. We might want to just make sure we're kind of being smart about this. If we're talking about this 1.24, right, we're always talking about tails. And in this case, since we had a not equal to, this is a two-tailed test. We don't only care about that positive 1.24 and above. We also care about this side of negative 1.24 and above. And already we can make some decisions and get rid of some answer choices here. 1, none of these is never the right answer. I mean, it could be theoretically, but it's usually just my catch for people who found something wrong. P-value should be small. P-value is a probability. It can never be bigger than 1, so A is immediately out. C seems very unlikely if we're talking about tail probabilities, because 1.24 is fairly unusual, not really unusual, but kind of unusual for a Z. And then we can kind of see something here. It looks as though D is half of B, right? If I had done a one-tailed test instead of a two-tailed test. So if I were good about this and did what I should do, which is look up negative 1.24 on the Z table, giving me a left tail, I'd find this value, which is this. I'd multiply it by 2, and I'd end up in B land, right? So that is one of the ways that I can sort of take these pieces and pull them apart and just put it in multiple choice instead. Other issues we're going to have to deal with, understanding the types of error in hypothesis testing, right? So these two questions do that for us. First one says that we're looking for a type 2 error in context. So for type 2 error, we know type 2 error is about failing to reject the null. It's usually the less worst of the two errors. And at some point, I must have told you what your null and your alternative are, right? Especially what your null is. So reading here, it says the manufacturer of a new type of light bulbs claims that they last on average 1,400 hours. So here's the claim, that the average is 1,400 hours, right? A hypothesis test is conducted to test this claim. Nothing about saying we think it's less, we think it's more, it's just testing it. So we want to show that it's not equal to 1,400 hours. So if we're doing a type 2 error, that means we failed to reject the null. So technically this isn't really our decision. We're going to say there isn't enough evidence, whatever, but this is what we're kind of stuck with. We have to fail to reject it, but really this was the truth and this is what we hope to be able to actually say. Again, you can also do the T on the second hypothesis. There's a T, our decision is here. So all we need to do is find a sentence that says we decide that they do last 1,400 hours, but it turns out the truth is that they don't. So making a decision that the mean lifetime is 1,400 hours, that looks good. When in fact the light bulbs do not last. Ding, ding, ding. Reading through them now just to make sure. Making this decision they do not last when in fact they do. This is actually a type 1. Making the decision that the light bulb, the mean is 1,400 hours when it does. It is. So this is actually the truth. This is a correct decision. And making a decision that it is not 1,400 hours when in fact they do not last. That's also a correct decision. So the only two that are actually errors right off the bat are A and B. And if you know how your type 1 is rejecting the null when it's actually true, and type 2 is failing to reject when it's actually false, then you should be able to work these out. As long as you do this work of setting up your hypotheses, right? Okay, so second one here is about how these things are all interrelated. A researcher performed a hypothesis where he ended up rejecting the null hypothesis. If he made an error in his decision, what type of error would it? Well, we just said type 1 is RTN when H naught is false. Type 2 is failing to reject the null when H naught. Oh, I totally failed on that one. You guys just pretend 10 o'clock me is better at this. It's true. Right, we don't want to reject the null if it's actually true, and we don't want to fail to reject the null when it's actually false. So type, but I was not even paying attention to that because the only thing that matters for us here is since he rejected the null, there's only one type of error we could be dealing with, type 1. Rejecting the null is also associated with power, but power is not an error, and type 3 is a made-up thing, just so I had 4 answer choices. Last of these hypothesis testing questions is the whole idea of what the heck a p-value really means. So remember, a p-value is all about what we do in a hypothesis test. We start with this initial assumption. We say, okay, well, what if the mean for those light bulbs is really 1,400? Well, what's the chance that I would then go out and do a sample and get out something like, I don't know, on the light bulb test, we're probably thinking it's something less. What if we ended up getting 1350 hours instead? What's the probability of that happening if this thing was true? So the biggest part of a p-value from our perspective is this idea that it's the probability of our sample being as or more extreme if, and this is the big thing, that big conditional bar, right? If it is known or if it is assumed that the null is true. If it's a fair coin, what are the chances that I would actually flip it 20 times and get out something like 60% of the time getting heads or more? And the only one of these answer choices that does that for you is E. See if I have 4 minutes to just quickly do this last one. The last thing that's going to be on the test for sure is the duality. How does a confidence interval, how's that related to our hypothesis testing? And we saw these a lot in class, right? We would make an interval and then say, well, do we think that the average temperature is really 98.6 or whatever degrees? Do we think that the average wait time is really 15 minutes? And you guys have been badasses at answering this. So here we can see we've been given a confidence interval and we've been told that there's a tourist site that says the average is 180. Looking at our interval, well, we can't say it's not 180, right? It's possible. It is possible that it's 180. So if it's possible that it's 180, we would fail to reject the null. We cannot reject this. We would be able to reject if it wasn't in there. So right off the bat, B and D are the only two that make sense. And then it actually says the null value falls within the interval. There you go. And then our level of significance. Remember when we're talking about this duality, we have two pieces to it. Outside means we would reject the null. We would say this doesn't equal 180. Inside is failing to reject, as we saw in this particular example. This is note card stuff, right? And then there's this one last piece here, and that's that our confidence level and our alpha level, well, they're complements of one another. So in this case, we know we have a 96% confidence interval. So if we want to find our level of significance, which is our alpha, I just need to figure out what the complement of that is. So 1 minus 0.96, this is 0.04, or 4%. And this is all about the idea that we're dealing with two-tailed tests. So if we're talking about a 96% confidence interval, which is a middle probability, we also know this outside two-tail probability, which is why we're always talking about these. Our alternative here would have been a not equal to, why we're always talking about these two-tailed tests in these particular duality questions. So hopefully that clears up all of the hypothesis testing stuff. Remember, I'll be around before class, the 8 a.m. class, I'll be there around 7. The 10:30, 11 o'clock class, I'll be around for my office hours from 9 from 9:30 until class starts. So stop by, ask me questions if you don't get something.